Assalamualaikum and welcome to the video. In this video, we are going to look at the first subtopic in chapter 2, linear motion. The most basic quantity that we can measure in linear motion is displacement and time. From the displacement and time, we can derive another quantity, which is the velocity. Velocity is the change in the displacement over change in time. So the equation can be rewritten as the change in the displacement is equals to the velocity times the change in time. Another quantity that can be derived from V, S and T is the acceleration. So acceleration is equals to change in the velocity over change in time. So we can rewrite the equation as change in the velocity is equals to A times the change in time. So as I've put in the orange box here, the delta S is the change in the displacement of the object in the time interval of delta t, and delta V is the change in the velocity of the object in time interval delta t. So we have four equations here. This is the first one, second, the third, and fourth. So these four equations will help us to understand the graph of linear motion. So if we continue to the second slide, so in the second slide, I hope you can still remember from your high school math, the way we calculate the gradient, the equation that we use to calculate the gradient. If we have a graph of y against the x, okay, and then we have a straight line here. So the gradient of the graph can be calculated using the equation m equals to y2 minus y1 over x2 minus x1, or we can simply write it as the change in the y-axis over change in the x-axis. If you look at the equation here, delta y over delta x, it is very similar to the equation that we have previously here. I'm going to highlight it using the yellow highlighter. So it has some similarities with the equation 1 and equation 3. See? So delta y over delta x, so the y-axis and the x-axis, alright? Okay, so this is the graph. Okay, the graph with a value. So I've put in value so that we can actually calculate the gradient. I pick a point on the red line, so this point here, and I label it as point A, and then the origin I label it as O. O stands for the origin. So the gradient of the line is equals to the y value, y2, which is 15, and then the x2 is 3. Alright, so y2 is 15 minus x1 is y1 is 0, divide by 3 minus 0, so you get 5. Okay, and then if we pick another point on the line, let's say this point. Alright, so if let me label this point as point B. So if we use point A and point B to find the gradient, to calculate the gradient. So point B is 20 and point A is 15 minus, so the x-axis is 4 minus 3, so 20 minus 15 is 5 over 1, so the answer is 5. So if you look at the gradient between A and O and B and A, or B and O, we will always get the same value, 5. So the gradient is constant along the lines. Alright, so any point on the line, let's say I pick a different point, A, B, let's say this is point C, this is point D, all the points will have the same gradient. Alright, okay, So how do we apply this concept to the analysis of graph of linear motion? Okay, let's say we replace the y-axis with the displacement, and then we replace the x-axis with time. So to calculate the gradient of the graph m, so instead of y2, let's say we pick a point, let's say this point. So this is point A, and then this is point O. So the gradient of the graph, instead of y2, we are going to use s2, and then minus with s1, divide by t2 minus t1. So this is actually delta s over delta t. So if we substitute the value, 15 minus 0 divided by 3 minus 0, so you will get 5. So, but the axis has a unit, so the gradient must also have the units. So the units for the y-axis is meter, so we put a square bracket, round bracket there, so we have m. And then the unit for the x-axis is second, so meter divided by second, so the unit for the gradient is meter per second. And the equation that we have here, delta s over delta t, is actually the velocity of the object. So this is the velocity of the object. So if we go back to the first slide, so delta s over delta t is the gradient of the graph ST. Alright, so the gradient of the graph ST, the gradient of the graph S against T is the velocity of the object. Alright, so means that if you choose a different point on the lines, let's say this point B, because we have the same gradient along the line. So along the line we'll have the same gradient, means that the object is moving with a constant velocity. Remember, the important point is the gradient of the line represents the velocity of the object. Because the gradient does not change, means that the velocity is constant. Okay, now if we have a different types of lines, so the line is no longer straight, instead it curves, alright, and it curves upwards. So if you pick a different point on the line, let me choose a different color. So this is black color, this is point A. So point B, point C, and point D. So all these points will have a different gradient. Okay, remember the gradient of the graph ST is the velocity. So the gradient, which is delta S, the y-axis, over delta T, the x-axis, it is the velocity of the object. So from point A, point B, point C to point D, the object has a different gradient. So if we draw a tangent to the point A, we can see that this is the gradient at this point, and then the gradient is getting steeper. Alright, it's getting steeper and steeper, means that the graph is telling us that the velocity is increasing. Alright, the velocity of the object, because the gradient is increasing, means that the velocity of the object is also increasing as the time increases. Alright, so you have increasing velocity. Okay. Okay, now I'm going to draw a different shape. Alright, a different shape. Let's say the shape of the graph S against T look something like this. Can you tell me how the velocity change with time? So remember, the velocity is the gradient of the graph ST. Alright? So if we look at the shape of the graph and we draw points, so points along the line of the graph, we can see that the gradient of the line, the gradient of the point along the line is decreasing. Alright, so we have quite a gradient here, and then the gradient start to decrease, and then finally the gradient goes to 0. So we no longer have gradient at the top of the graph. So if you have a graph that looks something like this, means that your velocity is decreasing. So because the gradient is decreasing, so the graph is telling you that the velocity of the object is decreasing. Okay, now I'm going to draw a different graph. Let's say you have a graph that looks something like this. Okay. So how do you think the velocity is changing with time? Okay, I'll leave it to you to answer this question on your own, and then we will discuss it in the Google Meet. Alright? Okay, now instead of displacement against time, we replace the y-axis with velocity and the x-axis with time. So if we calculate the gradient of the graph, so the gradient of the graph is equals to, now instead of y, we are going to use v2 minus v1 over x2 minus x1. Okay, if we pick any point on the line, let's say this point and this point, so point A and point O. So if we substitute into the equation, we have 20 minus 0 divided by 4 minus 0, so we get 5. And the unit for the gradient is, we have to look at the unit for the y-axis. Unit for y-axis is meter per second, and then unit for the x-axis is second. So if we divide meter per second by second, we get m as -2. So this is actually the unit for acceleration. So the equation here at the top, v2 minus v1 over x2 minus x1, sorry, t2 minus t1. Alright, it is actually t2 minus t1. So this equation can be written as delta v over delta t. This is actually the equation for the acceleration. So let's say we pick a different point on the line, so point B, point C, and point D. So every point on the line will have the same gradient or the same acceleration. So what the graph is telling you that the object has a constant acceleration. So this kind of graph, a linear graph of v against t, is telling us that the object has a constant acceleration. Okay, and the acceleration is positive. Alright, means that the direction of the acceleration is towards the right or upwards or right. Okay, towards the positive x-axis or positive y-axis. So if we go back to the first slide, so the first equation and the third equation is telling us that the gradient of the graph as t, okay, velocity is the gradient of st, and acceleration is the gradient of graph vt. Okay, now we look at the area of an object. All right, so the way you calculate the area, okay, let's say this side, the length of the side, we take as symbol h, the height. Let's say we take it as height, and then this side we take as the width. So the area of the rectangle is just height times with the width. What if instead of h, I take the width as t and the height as v. Alright, so now the area becomes Vt. If you look at the V and the T, it looks like a graph of V and T. Alright, meaning that if you calculate the area, let's say this is the line here, meaning that if you calculate this area here under the graph, the area under the graph represent what? Represent the displacement of the object. Alright, so the area under the graph represent the displacement of the object. Okay, if we go back to the first slide, so the height is delta V, this height is delta V, and this length is delta T. So if we go back to the first slide, so delta S equals to V delta T. So means that the area S is the area, let me choose a different color, the green one. So S is the area under graph VT. Alright, from here, without even looking at the graph, we know that delta V change in the velocity would be equals to the area under graph AT. Alright, A times T. Okay, let's go back to this slide. Okay, so this is the graph A against T. So if we calculate the area under the graph, so we have this line here. So area under the graph is this area, this shaded area. So as we have seen earlier, the area is equivalent to the value of delta V, which is the change in the velocity, and this is the area of a rectangle. So change in the velocity of the object is equals to the height is 25 times with the width, which is the time 7. So 25 times 7, 175. So what about the unit? So the unit for A, 25 here, is meter second negative 2, and then the unit for the 7 here is second, unit for time. So the unit for delta V is ms negative 1. So delta V is the change of the velocity. Means that if at times t equals to 0, your velocity is, let's say, I'm using a different color here, color green. So let's say this, at this point, your velocity u is, let's say, 5 meter per second. So after 7 seconds, okay, after 7 seconds, your velocity is going to be 180 meter per second. The reason because within this interval of 7 seconds, you have a change of the velocity of 175. So after 7 seconds, from 5 plus with 175, your new velocity is 180 meter per second. Alright, so that is the value of delta V. One more thing that I would like to add is that if you look at the title of the slide, I've added the term uniform here. Uniform means that the acceleration of the object will not change. Okay, for our syllabus, we are only looking at the motion with a uniform acceleration. So all of your acceleration versus time graph, you will have a flat line. So if you have, let's say, an object with no acceleration or zero acceleration, so the line will move down here. Okay, so if the line is on the zeroth of the A, so means that you do not have any the object does not have acceleration. So that tells us that the velocity of the object is constant. Alright, so the acceleration is the change in the velocity. Alright, so you only have acceleration when you have change in the velocity. Okay, I'll do one more examples because we have skipped the velocity against time graph, the area under the graph of velocity against time. So we'll continue on that. Okay, here is the velocity against times graph. Let's say the questions ask you to find the displacement of the object during the time interval of from 0 to 5 seconds. Alright, so to find the displacement from 0 to 5 seconds from the graph of v against t, so means that we have to calculate the area during that intervals. Alright, so this is the area of the triangle. So the area is equals to v times t, but because the area is just an area of a right angle triangle, so area of right angle triangle is just half of the area of the square. So I forgot the delta t there, the interval time. Alright, so we want the area during the interval from 0 to 5, so half times the height of the triangle, which is 25, the value of v. Alright, and then the interval is 5 seconds, so times with 5, so the value is 62.5, and the unit for velocity is meter per second. The unit for the time is seconds, so the second will cancel out. So the unit for the area or the displacement during the interval from 0 to 5 seconds is 62.5 meter. Alright, so I'm gonna ask you to do one questions here. Let's say the question asks you to find the displacement, alright, during the interval from 2 seconds to 5 seconds. What would be the displacement of the object during the intervals from 2 to 5 seconds? The clue is it is an area of a trapezium. Alright, so I leave you to that. So we'll continue our discussion in the next video. Thank you very much.